This will be video 3 for section 4.4. We've already set up the equations for the first 15 or so problems. So now I'm going to go through and selectively solve a few of them. So I think I'll solve part B on number 1. In order to solve this, again, it really just comes down to now we're just trying to maximize and minimize an equation. And we need to remember in this case that my input is B, and so I need to think about the restrictions on B. Clearly by the square root, B can't be less than 0, but if you recall back to the premise of the question, it says A and B both can't have to be bigger than 0. So if I think about domain, which is always something I should consider, we're going to have a domain of 0 to, and then B can be, I guess, as big as 20. So that should be my domain. Alright, so now it's just a matter of taking the derivative and then doing the first derivative test. So the derivative of s is going to be negative 1 plus 1/2 b to the negative 1/2. And let's clean this up and call it negative 1 plus 1/2 square root of b. So that's my derivative. I prefer my derivatives to be as fractions. And so I'm going to take the additional step of getting a common denominator and then multiplying top and bottom on this fraction. So should turn out to be negative 2 root b plus 1 over 2 root b. So I'm skipping the step where I show my work, but hopefully if you think that through you can follow with me. Pause the video anytime you need. Excuse me. So now I'm ready for my critical values. So I need to find out when the derivative equals 0. And that is going to happen only when the numerator equals 0. So I've got 0 equals negative 2 root b plus 1. Subtract 1, divide by negative 2. It looks like I've got the square root of b equals 1/2. So square both sides, and I get b equals 1/4. So I got a critical value at 1/4. So that'll go on my sign chart. I also need to consider where is my derivative undefined. And if I look at this quick fraction, I can see that when b equals 0, we have an undefined as a derivative. Now, that's not very significant simply because I had already identified my domain was 0 to 20, and so I'm going to be checking 0 anyway. But we'll still go ahead and throw everything on a sign chart. Again, 0 is the smallest we're going to go, 20 is the biggest we're going to go, and it looks like my only critical value is at 1/4. Again, my world doesn't exist out here, so I won't be checking any slopes out there. So I'm going to plug a number into my derivative, like barely bigger than 0. So let's find the derivative. Here it is. So putting a number that's barely bigger than 0 in is going to lead to a square root of a very tiny number times negative 2. This is going to be smaller than 1. So that means I'm going to get a positive value. And after 1/4, I put in something like 3. And this, I'm sorry, 9. The square root of 9 is 3. Negative 6 plus 1 is negative on top. The bottom will always be positive. And so I can clearly see that I have 3 values I need to be careful of. I've got the endpoints and I've got my critical value at 1/4. So s of 0, s of 1/4, and s of 20 is what I need to check. I plug in 0 to the original function, and I can see that the sum is equal to 20. Plug in 1/4, and I get 20 minus 1/4, which is 19. 20 minus 1/4, 19 3/4, plus 1 square root of a fourth is a half. And so I should get, what is that, 20 and a quarter? Then I plug in 20. 20 minus 20 is 0 plus the square root of 20, and I get the square root of 20. Our sign chart shows us that we have a local max at a fourth. We have a local min at 20 because my slope is negative as I approach 20, so it means I'm going down to wherever I am at 20. And then 0 is a local minimum as well because as I leave, my slope is positive going up. So the question said, find the values of a and b that'll make the number as large as possible. So the maximum is going to occur at 1/4 for b, and if b is a fourth, then our original setup said it has to equal 20, making a equal to 19 3/4. My minimum will occur at the square root of 20. So the minimum is going to occur when b equals 20, which would make a equal to 0. And so that would be the answer to part B on question number 1. All right, so let's move on and see what else we can do. Let's take a look at number 3, I guess. So I've already simplified my problem down to this equation, the perimeter. And now I want to maximize, actually on number 3, I'm looking to maximize perimeter. So once again, we should probably stop and think about the domain of the function. So the domain of L. So L can be, I guess technically it could be 0, although I guess that would make an area that wouldn't exist, wouldn't be 16. So I guess L cannot actually equal 0. So we're going to say 0 is, not including 0 is the smallest, and then we can let L be kind of technically we can let it be, let me think this through for a second. Looking up here, let's think about this. So L could be really large as long as W is very small. So for example, we have an area of 16 inches. So L could be, 100 inches long, which would force W to be very tiny. So I think, without giving it a whole lot of thought, that you could almost say that L could go to infinity. The longer L is, the smaller W has to be. So let's go with this as a premise until we find a problem with that premise. Okay, so we're going to take our perimeter equation and we're going to take its derivative. So the derivative of P looks like, again, I'm going to look at this as L to the negative 1. So it should be negative 64 L to the negative 2 plus 2. And let's just rewrite that. The derivative is negative 64 over L squared plus 2. So now I want to know when this equals 0, when it's undefined. Clearly L can't be 0, but once again we were already aware of that issue. And that's about it. So let's set it equal to 0 and solve. So I get negative 64 over L squared plus 2. Looks like I've decided not to do a fraction this time. Might as well switch it up a little bit. I still prefer that method. So I'm going to solve for L squared. I'm going to move the 2 over. So I get negative 2 equals negative 64 over L squared. I'm going to multiply by L squared. So I get negative 2L squared equals negative 64. L squared equals 32. So L equals positive and negative, but the negative won't make any sense. So let's stick with the positive. The square root of 32, which let's go ahead and move up. I get L equals, let's see, 16 times 2 square root, so it's going to be 4 root 2. So I get one critical value. And so let's go to our sign chart. Let's put 0 on our sign chart. Let's put 4 root 2 on our sign chart. And then we won't put anything else because we didn't find any other values. So we go to our derivative, which is here. And we plug in a number like 1. And I get negative. And then I plug in a number like 10. Oh, hold on a second. Here's another reason why I really don't like not putting my derivative into fraction form, because then it makes this step a little bit harder. So I'm actually going to go ahead and do it at this point. Getting a little messy here, I apologize. I need a common denominator, so he's going to get the L squared over L squared. So I get negative 64 plus 2L squared over L squared. That's my derivative. So now when I plug in a number like 1, I see that the top is going to be 1 squared. I'm going to get negative over positive is negative. And then I plug in 100 or so, and I get 100 squared times 2 is a lot bigger than negative 64. Positive over positive is positive. So I know that 0 is actually going to be a local, well, 0 doesn't even, not even part of the domain, so I guess it's not even a point, so I can't say it's a local anything. But I do, wherever I'm sort of ending up, my slopes are negative as I leave, so that means I'm going down. I hit 4 root 2, and then my slopes turn positive. So that definitely makes this a local min. And the question asked, number 3, what is the smallest perimeter possible for a rectangle whose area is 16? What are its dimensions? So I just found that L has to equal 4 root 2 to be the minimum. And if L is 4 root 2, then W is going to be 32 divided by 4 root 2. And my calculator is under my book, which leads me to 32 divided by 4 divided by square root of 2. And I get that W equals 5.657. And might as well figure out what that is. 4 root 2. And L is 5 the exact same thing. Okay. So it appears that our minimum perimeter is going to happen when W and L actually form a square. Alright, we'll stop this video, and we didn't find the perimeter, but I need to plug it in and we'll solve for P, and I'll allow you to do that yourself.